So, good morning. Good morning, everyone. I hope you're all having a very nice day. And welcome to, first of all, my office. It's supposed to be the morning now and it should be sun, but it's Norway, so there probably isn't today. And of course, welcome to our new format of webinar. We thought this time we can maybe meet more face-to-face. You get to see us, you get to see our offices, and most importantly, we get to answer your most commonly asked questions. So you know how much, most of you I think already know me already, and you know how much I care about answering your questions very well and very thoroughly. And to do this better, I got you someone today who would answer your questions best. Actually, I got you the mind behind RIIM's features and RIIM's characteristics and the RIIM network, the person who tells the developers what to do and how to do it. I have with me this morning our R&D Director, Ørjan. Good morning, Ørjan.
Good morning, Omar. How are you doing?
Very well. We decided to have this webinar in this new way today, to have it more interactive, to get more of a human interaction feeling. And I think our main goal today will be for me to ask Ørjan the questions I see that you guys ask the most. So today I will not be Omar, the applications engineer at Radiocrafts, but today I will try to be you. I'll be the user, and I will try as much as I can to pressure Ørjan into answering our questions. He's still my boss, I can't do it very much, but I can try. So I see most people have already joined. Maybe some people are still getting some coffee, but we have our coffees ready, so I think we can start. But first of all, let's very briefly, can you tell, I think we have some new people, some new listeners here. So can you tell us very briefly what is RIIM?
Yes, so thank you very much for introducing me, Omar. It was very kind words. RIIM is a sub-1 GHz wireless mesh solution. So it operates on 868 and 915 megahertz. It has all the good qualities of a mesh, which means it's self-organizing, self-healing. It gives very good coverage in large areas, and also due to the sub-1 gigahertz feature that we use. So there's no central management needed for it. So it's fully autonomous, and yeah, it's basically a very good wireless mesh solution.
Okay, and how do I communicate with the module? How do I give it the settings and the configurations which I need?
So compared to normal modules, or historically, modules have been modems. That means that they have had a serial interface, and you have your own microcontroller on the outside, which you can use to tell the module to send something or to receive something. In this module, you have the ability to write your own application inside the module. That's what we refer to as the easy application, where a customer can tailor. One thing they can do is they can make their own modem functionality with that, but they can also do the application which reads the sensors, controls something. So they have a lot of peripherals available, and they can do the whole applications with timers and events and whatever inside the module, which of course save them cost and space on their PCB.
But in what format do I write these?
This is the complete standard C. So there's no specific mystery language. It's standard C.
Mm-hmm. Very well. Okay, so we covered that RIIM is an IP mesh network, 915, 868, low power and high power, communicate with C. Where does this place RIIM? What use cases and what applications do you see that RIIM would work in?
Yes, so now we have, of course, had the product on market for 2 years, and we have hundreds of customers working with RIIM, and they do a great variety of applications, but we do see some kind of characteristics that repeats itself. One is the customers who need this battery operated mesh. So that can be for like smart irrigation, where you have a field where you don't have any power cables out to the field. It can be in a forest, it can be in a glacier, it can be in in a mine. So there are a lot of places where you don't have an infrastructure, power cables and stuff like that.
But if you don't mind me asking, how do you achieve this? How do you have battery operated mesh? Because I understand this takes lots of power for network maintenance and the mesh structure and so on.
Yeah.
So how do you achieve that?
So we achieve battery operated mesh by having a time synchronized network. So that means that all the communication, all the devices are synchronous, so they know the exact time, and they have agreement between each neighbor nodes when to have communication. So they basically sleep maybe 99% of the time, and they wake up at predefined moments where they have said, okay, this moment we will talk together. And if then they can wake up, one can send to the other, they can acknowledge that, and they can, and then they can go back to sleep for the 99% of the rest of the time again. So it's due to this time synchronization that we're able to get mesh routers, which is down to 100 microamp in current consumption. Okay,
it's very interesting. So I interrupted you. You were saying battery operated mesh nodes for applications where you can't really extend the power cables. About the use cases of RIIM.
Yes, and yes, also before we go further, I also want to talk a bit more about these battery operated mesh routers, because we have one of the challenges that you come asking me all the time was customer wants to know how long his battery lasts. Okay.
Yeah, that's
so that's the most common question, I think. What will the battery lifetime be? So due to this, we have developed battery lifetime estimator tool, which is available on our GitHub page, where customer can download it, where they can put in, because you cannot say I have a RIIM node, what's the power consumption, because it depends. How often do you send data? How big is the network? How many children do you have that also send data through you? So it's kind of a complex calculation to specifically for mesh routers to estimate the power consumption.
Yeah, that's true. I used this tool myself.
Yeah.
I can just paste the link for the people here.
Yes, it's also on the slide here if they want to have it, but you can also put it in the chat, of course.
Yeah. So this is very helpful, because it allows you to just like put in your network settings, and it just calculates how much the battery will last in years and days.
Yes, so you put in what battery you use, you put in all the information you have about the network, and then you get an estimation of your battery lifetime, and it's very handy. In this example, we have 2 times AA batteries, and we see that the mesh routers can last 4 years on this 180 microamp, which is the lowest, basically the lowest power consumption you have on the mesh routers.
Very well. So we were saying, the use cases of RIIM.
Yes, so battery operated mesh is only one of several. We also have customers who wants to have more control network, and a lot of the wireless technologies out there are based on sensor data, upward communication. But sometimes if you want to control some devices, you need downward communication, and that's a bit more tricky.
And which one is RIIM optimized for? Is it more for uplink or downlink?
Actually, RIIM is very symmetrical in its shape, so that means that it has the same radio properties upwards and downwards, and so basically it's symmetrical, and both ways work equally well, which is a difference from other wireless technologies. So we do see like control networks. For instance, they want to control solar inverters, or if they want to control like irrigation, which is a control or turn on and off water, or other things you want to control. We do see quite a bit of interest in that type of application also. And in addition, we also have customers coming to us with requests for very high reliability, because there's a lot of technologies out there which are a bit fire and forget. So that means that you send, but you don't really know if you got the message through or not. So they don't have any quality of service. So reliability and having like 99.5 or 99.9% delivery rate is also characteristics of many of our customers.
How do you guarantee that? How do you do that, the 99.9% reliability?
We do that by a lot of different features. Of course, you have the mesh itself, which gives you reliability, because if somebody parks a van right next to a big truck next to sensor and blocks your radio, you can route the packet through other nodes. So that is a reliability in itself. We do have, because we run a quite high data rate, we are able to get acknowledgement and retransmission on each link or in each hop, which is for me the most important thing maybe to reliability, because we retransmit each on the hop on each hop we retransmit up to 7 times, and we also can have an end-to-end acknowledgement, which makes sure that if you don't get an acknowledgement from your end receiver, for instance, which could be the cloud or something, then you can also retransmit based on that. So this means you have a lot of quality of service built into that. We do LBT, so we listen if the band is noisy before we send. We have frequency hopping, which means if you send once, it's interfered by some other radio. If you then send the next time, you almost always send on a different frequency, which might not have the same interference. So you kind of avoid interference at certain channels. And the last feature I would like to mention is the fact that we have something called AFA, which stands for Adaptive Frequency Agility, which means that we monitor all the hopping channels, and then we see which are the most noisy ones, and then we exclude them from the hopping pattern, which makes them, which means that we try not to compete if there's a lot of some channels which are very busy. We try to basically avoid them. This is a very fancy feature, which is very nice. So we do a lot of things to give reliability to this.
Yes, yeah, it's more than one measure. It's not only one thing. It's a combination of all these things.
Yes.
Also, you mentioned in the use cases, you mentioned the battery-operated mesh nodes. You mentioned high reliability for control networks, which is mainly uplink. Mainly downlink dominated. What else?
We see also customers who want to cover a big area, so that's why they want to use sub-1 gigahertz, and some of them then want also use the high power modules, which can deliver 27 dBm, which means you can have like kilometers between each node, and then by having a mesh, you can obviously easily cover like many square kilometers of area. So that's also some customers who are looking for that property. And we also have customers who are looking for like high throughput type of where they have a lot of communications, and yeah, so that's also key.
But doesn't high throughput require certain settings, which is not, kind of contradicts with the low power and high reliability? Like I would assume the three of them can't really happen together.
Yes, so that's true, and that's kind of a lot of what we do, or you are involved with, Omar, discussing with the customers, of course, because we do have customers who come with us with use cases which we cannot meet, because they simply might say that, yeah, we want this very low power consumption, the battery should last 10 years, we want to communicate every 5 seconds, and we want a very good reliability. And then we just say, hey, go and buy a cable. This cannot be done with wireless technologies. And sometimes we have to do that with customers, because we cannot do magic, even though some think RF is magic. So that's part of the role when we talk to customers, is to make sure that they have to understand what's important for them. And if the battery lifetime is important for them, then they have to design around that. And if they want high throughput, then so a lot of these high throughput customers we're looking at is basically all the nodes are mains operated, because it simply, so it's not necessarily a combination. And
so we have to recognize what's the user's most important priority for his use case.
Yes, and, the same thing we can say about big networks. I mean, some customers want 1,000 nodes in network. We can support that, but obviously then if all that traffic goes through a couple of nodes which are closer to the board router, then obviously those will not have a very low power consumption, because they have to forward the message from the 990 other devices. And if everybody sent every 10 seconds, then the network will collapse. So you cannot do every 10 seconds transmissions either from home devices. So there are a lot of trade-offs there that we try to assist the customers.
Very well. Okay. Yesterday I noticed there was a cake at lunch here at Radiocrafts. So can you tell us why is that?
Yes, of course. I think it tasted very well as well. So of course, yesterday we released the 3.0 version of our RIIM SDK, which is now available on the web. So that is that was very nice. It's been through extensive testing now in the whole of August and a lot of September as well. So that was very nice.
And what's new with that SDK? What additions does it bring above the 2.0?
Yes, so it brings a lot of nice new features. First of all, it's an improvement in power consumption for the mesh routers. It increases the battery lifetime, increases battery lifetime of 50%. So if it before lasted
50%.
1 year, so if it lasted 1 year before, now it's 1.5, which is very nice. It increased the throughput of data going up to the board router. So in a sensor gathering network, we increased the throughput. We did some major enhancement to the low level stuff like UART controller, where we now also support like RS485, and we did other improvements as well. So basically, yeah.
And what's the main motive behind these new features? Like, why these new features?
Well, that's a good question. Of course, we are very customer driven in our development. So basically, all of these features is introduced based on customer feedback. And of course, you more it's your role as the customer application engineer. You are involved with many of these cases, and maybe you can share a bit on how we work together with our customers when they maybe they bought the kit, maybe they downloaded the SDK, start working with it. How is our interaction with them, and how do we help them?
I think we have quite a good process going on. We try to since I'm involved the most in this, so I think we really try to. We don't only deliver the features of a product like RIIM, for example, but we also try to deliver the extra things which would make the user's life a bit more easy. For example, so we have the feature which is battery operated mesh nodes, and we have nodes which consume very low power. But that's not it. That's the feature. But we also, to help customers, because now like you have customers coming and say, how much will my battery last? And then you have to ask us, then we have to calculate, then we have to reply, and this takes much effort and much of their time, and it's not very flexible. So that's why, for example, we came up with this battery estimator tool. That would the user would just enter his network parameters, and then he will get a number of how much his battery will last, depending, of course, on his battery and so on. So, for example, we had many customers who haven't worked with co-op protocol a lot, and they come asking how to do this, how to do that. I don't have much experience with co-op. Can you help me? So this, of course, takes some of their time and halts their development till we have answers. So that's why we have this new co-op example that we can just, it explains most of the behavior of the co-op protocol and tells them how to use it and so on. So we try to not only deliver features, but also to deliver extra things which would make the user's life a bit more easy. And it's, I think we do this in everything, in customer support, in our content, even also here, like in this webinar. Instead of being just a presentation, we try to make it in a new way, which would answer most of the users' questions, allow them also to ask us live questions. So I think that this kind of process is very good, and it's the reason why I think most of our customers are very happy with what we do.
Yeah, that sounds very, very good, Omar.
And this also brings us to a point. Okay, so yesterday we released the SDK 3.0, and with all these new additions, how do you see the future for RIIM? What should we wait for? What's coming up?
Yes, of course, I cannot reveal everything, and everything is not decided, of course, either. But as I mentioned before, we do try to be very customer centric in our development. So that means that we want to listen to our customers and see what are any pain points left that we need to rectify. Are there any challenges that they see, or are there any extra features which can enable their business? Because we need to enable our customers' success. So we do have, and that's why we also are pretty agile in adding the features. What we are looking at, I can share some of the things. We are of course looking at the new frequency bands. We need to cover, for instance, some countries in South America in a better way. There's also other frequency bands that we can evaluate. We also want to help make the development environment a bit better. So we are working on integration into Visual Studio Code, which makes it a bit easier to work with, and more. So we will not. This is not the stop line. This is not the end line for the development, but this is a milestone where we have our cake, and then we start looking at the next time we will have cake.
Okay. There was actually a question I wanted to ask since the beginning. You were mentioning in the introduction of RIIM, you said that RIIM is an IP-based network, and then in the use cases you mentioned low power. But doesn't the IP protocol, it entails much overhead? How does that really work with having a low power and high efficient network? How do you do both low power and IP based?
Yeah. This is
why? And why?
Yes. So first of all, I can say a bit about the advantages of IP, because we have seen this as a trend over the last year, and what IP does is guarantees kind of interoperability end to end, because the whole world is based on IP. Your cell phone, your PC, this webinar is going over IP. So IP is everywhere, and we see a strong tendency for home systems and consumer systems now through protocols like both this Matter, which is called Connected Home over IP before. We have Wi-Fi and stuff. So basically everything in your house is based on IP. So it's a trend, and what it gives is the ability to more easily integrate the services together. So it means that the cloud system and the wireless devices are able to meet in a much better way, and we see it also with our customers that it's very easy to kind of integrate everything together. So that is the big advantage. So then you have this concern about IP being overhead, and there has been a lot of work over the last decades to kind of make IP more lightweight and make it available for like the sensors and stuff, like small microcontrollers. So the common terminology is often 6LoWPAN, but which stands for IPv6 over low power lossy networks. But it also includes protocols like CoAP, which is an alternative to HTTP, which is there to make it more lightweight. You have compression of UDP packets. You also have the use of CBOR application packets instead of JSON. So there's a lot of standardization work going into making it more efficient. And what we gain by that is the fact that we can, in a RIIM mesh router, we can send a CoAP message up to the cloud, where in a different continent where you have cloud server, and get the reply back. And we can do that every 15 minutes, and that will only cost us 1 microamp in extra current. And then that's every 15 minutes. And if you look at other wireless technologies like LPWANs, they typically use, if you use LoRaWAN at spreading factor 12, you will use more than 500 microamps. So 500 times the same energy just to send it to the base station. So we don't really see that using, for instance, CoAP and DTLS and UDP and all these protocols we use is generating a lot of overhead in terms of current consumption, because we do see that it only kind of contributes to 1 microamps if you do it every 15 minutes, and that's quite often for a sensor.
Yeah, I see. And since we are mentioning going outside of the RIIM network and like communicating with the outside world and outside servers and maybe cloud and stuff, how do you think about the security of a RIIM network? How secure is it, and what measures do you take to make it secure?
Yeah, so security has been on our mind since the first day we started on RIIM. So this was the first kind of specification part we started working on many years ago. So because you need to kind of have a secure network. So what we do offer is security on many levels, because as you say, you have the normal radio security. So that's kind of dealt with through both the fact that we have frequency hopping, which makes it much harder to for instance, jam. So you can't really, you have trouble jamming a network, which is basically a physical DOS attack, denial of service. And we also have network layer security or network layer encryption, which makes it protects from other hostile units to join the network and to start doing denial of service that way. So that's going on the radio side. And then, of course, we are connected with IP. So that means that there is also a threat coming through that IP network. And for that, we do have application layer end-to-end encryption as well. It's something called DTLS, which is basically it's part of the TLS standard package, I should say, which is also used for your secure web pages like HTTPS. So it's basically the same security that you use for those kind of web pages. Yeah. In addition, we also added encryption of the firmware files if you do over-the-air upgrades, because that's one of the kind of really dangerous threats if people can upload their own firmware to the devices, and because then they will own that device forever. So this is that's also so that is encrypted in a third layer, you might say. So that means you. If
so like
you
3 layers.
Then you have 3 layers of security for that type of applications.
Okay, so that was about the security of RIIM. So we spoke about the use cases, characteristics, why is it IP, the security, what's coming new. But after all this, how do you see RIIM fits in the wide variety of other LP1s available? Where is it, and how does it compare to the most commonly used LP1s?
Yes, as you said, there's a lot of other wireless technologies out there, not just LP-WANs technology, but you have everything from BLE and Zigbee that you use in your home to more application-oriented protocols like wireless MBUS for metering or Wi-SUN for electricity metering, which are more dedicated standards. And then you of course have LoRa, LoRaWAN, Sigfox, MyOT, and VICE and stuff. So narrowband IoT, which is in a license band. So you have a wide variety of radio protocols out there, and most of them are very good protocols because they're made for a specific application and made for a specific use case. For instance, if you want to have your heart sensor to your phone, obviously BLE is a fantastic solution for that. But if you want to cover a forest with sensors, you don't really want to use BLE because you're gonna have sensors on every second tree in the forest, and it would be a hopeless solution. So you have to kind of match your applications with the different technologies. And regarding LP-WANs, most of that technology is based on that you send data from sensors up to like a gateway or base station. That's how LoRaWAN is made. That's how Sigfox is made. That's how MyOT is made. And they're very limited in downlink communication. So that means that and because you send a long distance, you use a lot more energy. So as I mentioned, if we send a packet every 15 minutes with acknowledgement from the backend, that will cost us 1 microamp. But if you do the same with, for instance, LoRa at spreading factor 12, it will cost you more than 500 milliamp, and then spreading factor 11, it will be
Huge difference.
50 microamps and so on. But so you see the difference in power consumption there. And also a lot of these LP vans, they don't have you don't have acknowledgement, so you don't really know. So sometimes you can have like packet delivery rate of down to 95%, maybe 90% in a city. So then you have to ask yourself, what type of delivery rate do your use case need? Is it okay to get 90% of the packets, or do you need 99.9% to have a good system? So that's something that every users. But if you want to gather data in a large area and don't send too often, then LoRa is a good technology. But if you want to have, for instance, control data down to battery operated devices, it's not good. If you want to have a low latency under control, it's not good. If you want to really have somebody sending data every 15 minutes with a coin cell battery, LoRaWAN is not good. So again, it depends on the use cases. But for right use cases, it's fantastic technology. So this also covers a bit of Armando questions I see on the side, how you compare LoRa and LoRaWAN.
Yeah.
So for the right use cases, that's a very good technology, and for the wrong use cases, it's basically wrong.
So there is not one technology which is the best at everything and it fits all use cases, and it will.
No, it's definitely not, and that's why we started this presentation by talking about our applications and our use cases, and where we see. And obviously, if use case fits LoRa very well, we don't get that many of those customers because they will then probably end up using a LoRa, which is better for them. But what we get are all the customers who see that RIIM fits better their need.
I see. Okay, so from what I've seen in my time trying to answer some customers' questions, I see that sometimes customers are in countries which really don't abide with the standard regulations. In cases of, I think it's mostly the frequency hopping channels. So what countries can I use RIIM in today with the offering that we have today?
Yes, that's a good question. And question, of course, 2.4 gigahertz is more simple because it's basically worldwide, and 7 gigahertz is not. So it is a bit more challenging. So this is the rough outline that in the US and US and South America and Australia they use 915. In Europe they use 868, also covering. I guess most of Africa it's not easy to get the regulation in all countries there, but we do see it's being used in like Africa, Middle East, and also some countries in Asia, like they use 865 in India, and they also allow 868 in Pakistan, Bangladesh. So it's basically about how it looks like, but also you have local adaptation. Like now we were, for instance, looking at adaptation for Vietnam, which requires a certain subband of 915 that they're using. They don't use the whole band as US. They cover a subband of that. Australia do the same. We talk to our customers again. We figure out what countries they need to support, and then we help them with that specific local regulation. So and you, Omar, did an application out covering this as well. So for more details, it's also an application out on our web, which they can download, which goes into more details.
So we created RF settings which can just be entered in the AC application, which will then make RIIM operate in some of these countries which we had a tailor, which we tailored a custom.
For the low power module, you can basically, it covers both 868 and 915. So you basically in your code, you said you have one line of code saying set frequency band, and then you choose one of the bands we're covering. So it's kind of one line of C code to change that. On the high power side, we do have more filtering, so that means that there we have one module for 868 and one for 915.
Okay, this can get a little bit hard to follow. So we have now different countries, and they have high power, low power, 915, 868. what are the different module types of RIIM, and when to use this one, when to use that one?
Yes, so this is we have 3 hardware modules, which is the 1882, which is 14 dBm output power, which is covers both Europe and US. So that then you can use it all over the place, and that's also the most power efficient one if you just want to use battery operated mesh. And it's, I think, most of our use, I think it's the most popular one of the modules, the low power. Of course, it's also lower cost for the end user. And then we have 2 modules, which is high power modules, which give 27 dBm output power, which you can use in those countries where that is allowed, which of course you can use 27 dBm in the US with frequency hopping. You can use it in India at 863 to 865. You can also have one channel for high power in Europe, but there are some countries which don't really allow high power, like some countries in Asia, for instance. So you have to do some investigation into the local regulation, but of course this application note that we have is a good start. So that's the modules. Yeah, please go ahead.
If I want low power, I can use 82 or 92. No, if I want low power, it's the 82. And if I want high power, then I have to choose. It's either 82 or 92, depending on the frequency regulation and what band can be used. But
they are, of course, pin compatible. So that means that you can, you just have to know, you can still cover both, but you need to then have a different bill of material for the two variants.
Okay.
So this is this slide that is behind us is basically showing the different the important parts here. We have the modules, which is the 3 modules. We have the kits, which are on stock.
Have one here.
Even though and that's not the one we're sending to the customer, but we do have stocks of kits both here for our distributors, and we also have stocks on DigiKey, which is also a handy way to get hold of them. Which, even though supply of electronics is terrible these days for all, we do have stock. So these are available. And of course, the SDK, the new 3.0, is available on our web page for downloads, free of charge, of course.
So the modules are ready, the development kits are in stock, and the SDK is released. Everything seems set.
Yes. So it's this is so just to get started, it's just order your kit today and then start being part of the RIIM family.
I certainly look forward to that. This was very informative, Ørjan. Thank you very much. As you can see, I tried to cover most of your questions, most of your concerns.
We do have a couple of questions in the chat, which we'll also go through.
I was just going to ask them also if someone has any more questions, they can let it in. And we can see that Armando, he was asking about comparison between LoRa and LoRaWAN and RIIM, and we kind of covered that.
Yeah, as I said, I'm not going to, even though we don't supply LoRa, I'm not going to talk down LoRa because I think it's a good technology, but it's best for some use cases. And if you want to gather data like every hour or every 2 hours, it might be okay. If you want to cover data every 10 minutes, then you might have a challenge, and also for control data. So again, it depends on the use cases. I also should note that we are talking about sending data every 15 minutes or 10 minutes, or even more often. We have customers going down to 1 minute. Narrowband IoT also claims, for instance, 10 years battery lifetime, but their calculations to get 10 years of battery lifetime is based on tubing batteries and transmissions once every day. And of course, so you have to kind of, when you look at these technologies to compare, you have to look at the use cases again. If you send once per every day, then probably Narrowband IoT is a very good technology for you, but it's really not what our customers is looking for, to send once per day.
All right, and he was asking also about the battery. Why do we use 3.6 and not 1.5?
That's just because we have a lot of industrial use cases where they use these lithium-thionyl batteries, which are 3.6 volt, which is we're coming a bit. We have been spending a lot of time in the metering industry, and that's basically anything is just used there. But there's no reason why you can't use the 1.5 volt. Obviously, you need to put them in series to get 3.0 volt, and the system works fine there. And in the battery estimator, you can put in your own. You can just by selecting the batteries and playing with this efficiency coefficient that you can do that. You can basically set up your own capacity. So you can able to. There's no reason why you can't use it. The power consumption is, of course, better with the lithium-thionyl, so the numbers get better. But there's no problem using other technologies as well.
Thank you very much, Ørjan. This was very helpful. I think we covered lots of the most commonly asked questions and frequently asked about topics. I hope that this new format is more beneficial for you guys. And please remember, if you weren't here today and you just have more questions, feel free to send them to us at support@radiocrafts.com. For ordering the development kit, you can go to DigiKey, or you can contact orders@radiocrafts.com. It's order, not orders. Yeah, if you have no more questions, then I think that's it.
Yeah, this webinar will of course be posted on our yes. YouTube page as well, so you can go and you can send the link to your friends. So in case you have a colleague or something which you think this is valuable for, so please share that if needed.
Again, this is certainly much more fun than me doing webinars alone. So thank you very much for taking the time to join us today.
Yes, thank you very much for having me.
And for our guests, I hope you all do well. And I guess I'll see you in the next webinar, which will be the last Thursday of next month. Till then, have a nice time.
Okay, bye-bye.
Bye-bye.